Hello everyone, Jeff here again, and in this video we're going to talk more about the Keyence vision laser measurement sensor that Keyence has come out with here in the last few years. So in some of our other videos we talked a little bit about the setup and some of the mechanical components such as the sensor head, the amplifier, and then obviously some of the wiring of the sensor. So in this we've already got my umbilical, if you will, or it's the sensor head cable, as Keyence would call it. And I've got my Ethernet cable connected to my computer, and then I've got power onto it. You'll notice that I've got power into it. I do have a program that's already established inside of it that's failing all of it. And then obviously there's a red light on top of my sensor unit, and that's because I'm failing every particular image that it's taking. It's set on an automatic, or not an automatic trigger, but it's set on an internal trigger, so it's constantly triggering, I believe, like every 50 milliseconds or something like that. Obviously, I do have a link connected to it. The laser's on, and my status is, yeah, we're good to go. We're not aired out or anything, but obviously we're failing on our images. If we were passing our images, obviously this light here would be green. So I'm going to go ahead and open up the program that I've already downloaded and installed on my computer. And then after I move this sensor up, you'll notice that it's starting to see the table underneath of it. I want to go ahead and show that there's a laser beam basically that's coming out of it that's scanning for, if you will, the actual physical measurement of the image around it. And then obviously the camera is still taking live images, again, every milliseconds or whatever it might be. So what I'm going to go ahead and do through our program here is I'm going to go ahead and drop down and create a whole new program. I'm going to go ahead and say yes, okay. So it should be in we got to switch over to the program mode, which should be okay. And now it's going to go ahead, and the sensor head itself is going to flash green, basically signifying that there's nothing there and that we would need to set it up. So we have the opportunity to set it as a line mode, which would be if our target's basically moving down a conveyor, and so that we can measure that distance as a constant. We also have the opportunity to do a scan mode, which gives us that 16 different points from whichever as long as it's within our vision window, if you will. Our target needs to be stopped, or at least pretty darn close to stationary for us to do that. So I'm going to go ahead and go with the scan mode just so we can kind of get a general idea and see what's going on there. We're going to go ahead and go through the sensor setup, and it's going to give us the same 4 steps that we would do as if we were doing something similar to the Keyence IV series sensor itself. So it's going to go ahead and do this flashing thing, and allows the and it's going to go ahead and also do this constant flow here to allow us to get our constant brightness that we would need. If we would need to do like a brightness adjustment, we could do like automatic brightness adjustment. Allows the sensor to control and do all its flashing that it needs to bring us into the what it considers a proper brightness. It's going to use an AI function within it that's going to do that for us. We have the opportunity to do like measurement direction, so we could obviously allow it to do its normal function where it's going forward, but we could also reverse it. We could do like a high speed versus high sensitivity. We obviously want to reduce most often our measurement noise, and then we can have some adjustments on that too. Trigger options, again, I'm going to use the internal trigger at 50 milliseconds. I could use an external trigger if I have the discrete I/O hooked up, but obviously if you look at my sensor over here, I do not have that hooked up. In fact, you can actually see that on the trigger itself here, so I might just leave that right there for us. Once we would have all that set up and we'd be happy with that, we're then going to go into the next step, which would be step 2. We're going to go ahead and say we need to register a master image. So at this point you need to make sure your sensor's set at one particular point, and you would need to then register your image. So at this point I'm going to say go ahead and start master registration. And so it's measuring its world around it. Obviously I'm in the wrong kind of position because it wasn't able to detect anything. So I'm going to have to do like another register master image. Let's see here if I can't maybe get... Okay, so in this particular application, we're able to get something a little bit better. We're able to kind of register it. Wherever you get these dashed lines like this, it's not able to register any of that information there. So it's not ever going to be able to measure the difference between the two. Once you're happy with that, then you would go ahead and do that. And you could say, hey, you know, I'm maybe adjusted to 20 degrees off or something like that, and you'd be able to adjust that particular application. We'll go into our next step, which would be setting our tools. Close that. Maybe we want to add a tool, so we want to do like a step height, for instance. We would say, okay, what's our difference between maybe this point versus this point? And we'll say, yeah, I want to keep them at small. You could also do normal or large. So it's saying right now we have a difference of 16.5 millimeters, and I would say that's pretty close. 1.6 centimeters from the top of this this little measurement, or this excuse me, the contactor that's connecting the power cables to the sensor amplifier to my tabletop surface is roughly about 16.5 millimeters. So I'm pretty comfortable with that. So then we'll go ahead and hit next, close, and then we could adjust our threshold from, say, maybe we don't want to have it at 160 millimeters less and 160 over. So we would adjust our thresholds basically to meet that need. But for us, it's just kind of a rough estimate, so we're just going to go with it. We might want to say, hey, instead we just want to have like an actual physical height of something. So what's the height of the tabletop from the sensor head itself? We're able to say, okay, well, it's roughly 44.2 millimeters, obviously in the opposite direction, and that's, yeah, that's probably pretty close. Well, yeah. So it's kind of working in a little bit different scenario situation here. So just kind of keep that in mind, that that's going to be kind of more of a set point there that you're going to have there. You could also do more of an average height if you wanted to do that. You could say, well, what's our average of maybe our tabletop surface? And then go ahead and say next, normal. So it's saying it's a plus or minus of a 15 millimeter window basically, and then obviously your limit adjustment down here. So, and we're looking at, you know, roughly the 44.2 millimeter and the 43.8 millimeter based on our window of criteria here. So I'd say we're doing a fairly good job here at this point for our measurements. Go to our next step. Our next step is obviously going to be, and I'm going to go ahead and set the sensor down here. Our next step obviously would be setting our settings. So what do we want out of our 10 outputs? What do we want? We want like our total status. Do we want to say, hey, our system's running? Are we busy? Aired out? Alarm? Position adjustment? Obviously, what's the average? Is our tool good or bad, basically, is kind of the tool adjustments that we have there. So just kind of keep those in mind. You can also shut them off completely if you wanted to use just nothing more than Ethernet IP. I wouldn't suggest you use only Ethernet or Profinet or DeviceNet or any of that when you need to have the application for a fast vision system. The latency with Ethernet or Profinet comes into play on that, and you'll lose some time there that you might need for a critical process. So keeping it discrete is definitely an important and critical consideration. Once that's done though, you would go ahead and complete settings. Your program is going to be saved, and so go ahead and say yes. And it's going to go through the time that it takes to set that up. And then once you've got that, you would go ahead and select the program and hit run. And obviously it's going to go ahead and trigger, and it's going to fail all of them because we're out of our particular window. And it's going through and it's actually scanning everything based on our criteria. Okay, so now we're back to kind of where we were. We're kind of at our, so we're kind of at our measurement window that we're kind of looking for here. I mean, obviously some of our stuff we would want to tighten up our thresholds on, and we'd also want to make sure our camera's not moving. As you can see, the camera has moved because, or the sensor itself has moved because I'm holding it with my hand. So don't do that on a physical application that you would need. But I do kind of want to show like what it's actually doing over here, this sensor itself. So you can see on the top that the camera itself is triggering in a flashing manner. So it's physically taking a picture of the part beneath it, and then it's also running this laser across it to read out our measurement, if you will. And then it's also giving us the application, whether we're passing or failing, on the top there. So that's just the way to how to set up a standard scan mode, if you will, through the iX series sensor, as well as through the iX Navigator software that Keyence puts out. So in another video, we'll discuss the line mode. Anyway, so thank you all for watching, and always remember to stay safe.